topic you want to score, my friend. That's not a fun topic to score in. Are you finding it comfortable?
To an extent, yeah, it's fine. Okay.
It will be only fine. It will not be. The problem when I say it's not that scoreable is because you will have to put a lot of effort into this topic to score. It is not that difficult as rotational dynamics to understand. Meaning you can't, you won't get that magnifying effect in terms of your understanding. When the topic is tougher, your intelligence gives you a magnifying effect in terms of the difference between you and the others. Fluid dynamics is something where intelligence matters, is something which does matter, but only in the conceptual questions. The standard stuff does matter. That's all. So you guys don't even have Coriolis and shit now, huh?
No.
So none of that baseball spin, none of that shit you guys do now. Everything is like
No.
You guys have laminar flow and
yes.
Okay.
Yeah.
You guys have Bernoulli, Torricelli?
Yes.
Okay, it's not. There's still enough shit. There's still enough shit there, but some weird stuff is gone. Okay. All right. What is 3:40? What time did we start, dude?
2:10.
So it's been an hour and a half. When is your next class?
I guess Wednesday again. Wednesday.
No, not my next class with you, my friend.
Oh.
You have another round today?
No, sir, that's it.
We are done today. Then we can spend a little bit more time. Tell me, do you have any more doubts for tomorrow's exam? Anything to discuss?
Sir, do you think I should practice physics now or like chemistry?
You just fucked up a little bit in the exam. That doesn't mean you should get scared. So, up to you, dude. How does it matter what you practice? Which one do you find more complicated now?
Sir, I really don't know what type of questions will come, so I can't really say.
Show me a chemistry paper.
The one we had?
Yeah. I think this week, what do you have as syllabus, chemistry?
Sir, geometric and structural isomers.
There's not going to be that much, but chemistry paper will be long today. It'll be
it's advanced paper also, so.
No, it'll be lengthy for you, and plan for at least 45 minutes to 1 hour this time in chemistry. Isomerism will be a lengthy paper. It'll take a lot more time than the previous round. It will not be that difficult. You don't need to worry so much. I think you are quite competent in all the standard isomerisms. Geometrical also, you have already learned enough, so it should not be a problem. The chemistry, if you feel confident, go ahead. You can work on physics. Physics, ma'am, how confident are you?
Kind of. I think I need more practice. Yeah.
And math,
if I can do that. Maths are vectors, sir.
That's
also kind of.
That's cheap, yeah. You've done it in physics enough.
No, but like
3D plus vectors or only vectors?
3D plus. I mean, no. For now, vectors. Next exam will be 3D plus vectors. So kind of.
Yeah. 3D plus vectors, it'll get interesting. Little bit more interesting. But if you're doing only vectors, there's nothing there.
Yeah. Oops.
Vectors only matrices or nonsense they might combine, no? That shit is there. You've done matrix determinants?
Yeah, we have.
What topics are you? You're in 11th only, no?
Yes, sir. Yeah.
You've done complex numbers also?
No, that's a second year topic.
Okay. They
after
vectors now?
Yeah.
They did. Okay, so I'm not going to poke. Not my point there. Complex numbers, they are not doing.
No.
Okay. I do not know max order. I don't want to poke. So, any other questions in chemistry? Anything to discuss in chemistry?
Wait, I had one doubt and one question. 1 second.
Your mother tongue is Telugu or Kannada?
Telugu, sir.
Your name, the second part of the name sounds Kannadiga type.
Oh.
Where are you guys from?
Sir, Telangana, sir. Khammam,
okay,
Yeah, sir, the question is the number of geometrical isomers in SF2, Cl2, Br2. Yes. Yeah. Yeah.
They asked this.
It's in our workbook, sir.
That's not something which you need to bother about at this stage. It is something which which you need to think about when you're doing coordination compounds. But since you asked, let me just explain. If you're going to be having something of this sort, okay, the way to count your number of geometric isomers goes like this. So it's something similar to what you'll be learning in coordination compounds much later, officially in 12, as Ma2 B2 C2 type. So let me just use the principle which I was using there over here. In this case here, sulfur is going to be having a square planar in the middle and one group up and down. Correct?
Yeah.
Now, let's look at each possible case over here. So what you need to do is you need to go for how, when you are checking isomers, what do? You need to go for a mutually exclusive approach. Correct? In this case here, the way to get a mutually exclusive approach is
fixing
the groups at the 180. Okay. Then you end up having whatever is left over going here.
B2.
B2, C2, okay. Square mein chalega. If it is that on the square, then there is going to be only two possibilities. I can have a BB diagonal and a CC diagonal, or I can have a BC and a BC diagonal.
Two chances, yeah.
Correct? Huh? So, with my A and A at 180 degrees, I have these possibilities. Next is going to be
B and B. A and B.
B.
Or C. Yeah.
At 180 degrees. We'll come to that. A and B at 180 degrees now. What is left over in the middle now?
This AB C2. Yeah.
AB C2. That means now in the middle, I can have an AB diagonal, which will be followed up with a BC diagonal, or I can have an AC diagonal, which will be followed up by a BC diagonal, or any other possibilities available?
Oh, no, that's it. No, that's it.
Are you sure?
Yeah.
Yeah, that's it. So effectively, these are your only cases now. So again, two possibilities now. Now, let's look at the last one. Not last. Let me not. So now let's look at the next one. So what's going to be happening here? Now, in this case here, we did not have any problems with the first one there. Why? Because in the first one, there was an AA opposite. That means these are all fully mutually exclusive. Correct? The first fellow had an AA opposite. So there is no way there is going to be any AA opposite in any of these cases. That means all cases in possibilities 1 and possibility 2 were fully mutually exclusive.
Yeah, so there will be more than 4 for sure.
Basically, there's going to be 4 now directly. We can add
4 for sure. Yeah.
Now let's try for an AC diagonal now. AC opposite now. What is left over in the middle now?
AC B2.
Correct?
Yeah.
Now, what are the possibilities here? I can have an AC and a BB diagonal, or I can have an AB
BC.
BC. Problem here is this. Have a look at the second structure here. This was an AC, BC, and an AB, which is same as this guy.
Yeah.
So the idea here is, in this AC here, make sure there are no repeats of AA or AB.
Yeah, they're not there. Yeah.
None of those diagonals are allowed. That means this is not allowed because an AB diagonal. Why should it not be allowed? Because that has already been counted in the previous case. Because what did we do when we did the AB opposite there? We counted every possibility with AB opposite. That's what we did.
Correct. Yeah.
Right. So when I counted this here, I counted every possibility with AB opposite. So now I should not count this again. So how many do I have total?
5. What if we have a BC? Where is that counted?
Think for a second. What did we do just now? We basically took mutually exclusive cases. How were they mutually exclusive? Because we took all diagonals. Diagonal now 180 degrees with A present. Correct.
Yeah.
Now, can you draw any structure for this type where there is no A present?
No.
180 degree thingy.
Oh, yeah, you can.
Without A on 180 degrees.
Oh, no, you can't.
I
Oh,
got
yeah,
it.
you can.
Because all of these are 180 degrees also, na?
Correct, correct. Yeah, that's also it. Yeah.
So there is no way I can draw anything else. That means I have already taken everything and I'm done.
I see. Okay.
Instead of doing AA, AB, and AC, what else can you do? You can go for BB, BC, BA. Doesn't make a difference. In the
Okay,
case
yeah.
of HF2, Cl2, Br2, instead of A, you put F, Cl, Br, whatever. You understand the principle here?
Yes, sir. Yeah.
So how many geometrical isomers?
5. Yeah.
What
Answer
are
is
the
again
non-trivial?
5.
You understood how it works here cleanly?
Yes, sir.
You need to bother about this
Kind
now.
of. Yeah.
You don't need to bother about this so much now. It is only going to be a kind of for the time being. You'll learn more about this when you're doing coordination compounds. अभी के लिए ज़रूरत नहीं है. This is just, yeah, you now know what to do if that shows up. So you have some doubts about why I picked AA, AB, and AC right now. I think that's the only thing which is still like hanging by a little bit of a thread in terms of understanding. That's okay. I'm okay with that part being hanging there. You think for yourself why we did that. I already given you the explanation actually. You just need to process that a little bit more. Any other questions?
Sir, it's an assertion reasoning question. The first statement is benzaldehyde forms 2 oxanes on reacting with NH2OH. Sir, can you show how the reaction will be like when it reacts?
I'll just show you. It's not that complicated. So, now first off, what is benzaldehyde? This
CHO.
compound is benzaldehyde.
Yeah.
Yeah. So now
Yes.
I'm going to be redrawing this slightly differently. I'm going to draw it like this. Okay.
Yeah.
The pH here represents the benzene.
Phenyl. Yeah.
Now I'm going to be reacting it with hydroxylamine. Okay. Hydroxylamine.
Hydroxylamine. Yes.
Now I'm not going to be giving you the exact mechanism of what the fuck is going to be happening here. What is going to be effectively happening is this.
Yes. So, but then why doesn't the OH and H?
No. Do not ask me questions now. We're not going to be discussing that part here. But since you're asking why the fuck not, yeah, that's not that difficult to answer for you. What happens over here is this carbon here is attached to a highly electronegative oxygen, double bond O.
Yeah.
This carbon has a high delta plus. Yes or no?
Delta minus. Yeah.
This delta plus will be attacked by something which is going to be a donator of electron density, correct? It's a delta plus, correct? What does delta plus mean? It means it has more electron density or less electron density?
More. Oh, less. Sorry, delta plus means less.
Delta plus it has less electron density.
Less. Sorry, yes.
That location is targeted or it is attracted to what? It is attracted to something which has more electron density?
Yes, obviously.
So something which is more basic will try to attack that?
Yeah, so the OH will come.
If I have ammonia and water.
Oh, okay.
We talked ionic equilibrium just before this. Just the previous chapter.
Okay.
Why are you failing to connect what you learned there over here? Just because it's not organic doesn't mean this is not connected there.
Okay. So then, okay, fine. Yeah. So then, phenyl. Okay.
If the OH is going to be the one attacking, that will leave. Okay, you want to basically, your real question was, if I'm getting water out, why is that OH not going out? Correct?
Exactly. Yeah. H
That
and
will go
OH
if that OH was doing the attack.
But then the NH2
I doing the attack now is nitrogen.
Yes, makes sense.
So those two hydrogens go with the oxygen on the other end.
Yeah.
Yes. So what you end up getting is effectively going to be something like this. And of course, we will also get the other type.
Okay, that was my question. Do both of them form, or like how?
Yeah, you will get both.
Can you differentiate between them? Like, if you see it physically, like.
Obviously, you can differentiate between them better. Come on, these two are geometric isomers.
Okay. Yeah. Okay. Yeah.
What the fuck was that question, really?
Sorry. They'll have different. Yes.
They're different compounds. They have different properties.
Correct. Yeah. So when you're writing the equation, would you write both of them, or would you just write one of them?
Repeat.
If you're writing the equation, the reaction, sorry, would you write both of them or only one of them? Okay, got it. Yeah.
You should put both.
Understood. Yeah.
So both are different compounds, so you'll have to put both, or you can put one of them and mention geometric isomers of this are applicable.
Okay.
Ideally, you should put both. If I was writing a paper, I would put both.
Okay. Yeah.
Any more?
Yes, no, sir. That's it.
Sure?
Yeah.
Good luck with your exam tomorrow. And
yes,
try to make sure you invest time on chemistry tomorrow. You're going to require it tomorrow. Isomerism, you cannot do 25 minutes. That's not going to happen. You'll require 45 minutes minimum. You might require even 1 hour. Have fun.
Okay, sir. Yeah.
Good night. Good afternoon. See you.
Yes, sir. Have a nice day. Yeah. Bye.
Bye.